drift back, which makes it 30. Yep. Usually not. Usually not. Usually you can just do a step. How are we looking here? So I'm a little ahead of Argus. So I'm going to hang out here for a bit. Why am I bobbing?
I can probably see you better if I'm pointing the camera down.
That's weird.
So that doesn't make sense. That would mean you would have to be off to my right.
I am off behind and to the right. Or forward and what? Wait, what am I
Yeah,
looking at?
forward.
The one you're seeing in down cam, that
6.
glow is this. Is your lights.
Oh.
I bet if you turned out all your lights, you could see.
Gotta keep you on your toes. Turn off the center
Just for fun.
cathodics.
Yeah, now you can see where Herc is.
That was you, right?
Say again?
Yeah. Okay. Panic. Sheer panic.
Oh, God.
Sure. Yeah.
Video person's worst nightmare.
What's this one?
Yes, slightly. Yeah.
Thanks. Oh, I see your lights now. Kinda. Yep. There, I see ya.
There we are. Look at that.
Should I?
You could now. Let's not. We'll get a lot more tether by not doing that. So I'm thinking let's not bother.
Technology has enabled more scientists to participate in research through telepresence. We have groups of scientists and the Scientist Ashore program who can follow the dives and make their contributions. At some point in this dive, I would appreciate hearing from someone at the Inner Space Center at the University of Rhode Island about their background. And
Okay, so I'll head down.
how they came to be part of this program. Dr. Ballard had shared a story that was he was in the Cayman Trough and it in a submersible, and imagine it took 6 hours to descend and 6 hours to ascend. So having these ROVs provides an opportunity 24/7 to collect data and share it with the world.
Understood, yeah. No. Sure. We probably need to go another 30 meters or so from there to there, kind of thing. At least. Sure, yeah. Still looking good there, so.
You're heading down?
Yep.
So if you're heading down, you're heading this way? This way. So you're heading more away from me?
I'll be going
Towards
kind
me?
of perpendicular, parallel to you. You should act that out again.
Try again?
Yeah.
Gonna go this way.
Oh,
Leave me alone.
he moved. No, she's blurry. Too active. All right, I can get another one in.
So Susan, I think earlier you had a question about HYPAC,
Yep.
about how it was used.
Yes.
I don't know if Ben's in a position to answer, but if not, I'm more than happy to give it a stab.
Sure.
Sorry, what? What's the question?
There was a that's okay, Ben. No, if you're too busy, it's not a
Yeah,
problem.
go
I can
for it.
answer. But it was how HYPAC is used and what we use the software for.
Oh, there you are.
Yeah.
Yeah, sure, no worries. Okay, so Ben's actually
You
busy
probably
at the
spin
moment
around.
doing ship moves and working on the multi-beam survey. So I'm more than happy to give you a quick overview of what the software is. So HYPAC is what our navigators use. So our navigators work very closely with our Hercules pilot and our Argus pilot, and with the bridge as well, so with the first mates and the captain, to be able to see the position of the ship and the position of both Argus and Hercules relative to the position of the ship. And what they're able to do is they're able to give bearings and headings to our target sites on the sea floor, which means they can give very good descriptions of where they actually want the vehicle to go. But because the systems we use on board with our ROVs is what we call a two-bodied system, it means we have to make the ship move, and then we wait for Argus to follow the ship, and then Hercules will then follow again. And we have a certain amount of tether within which we can work within those parameters. So we're able to monitor on HYPAC the position of the ship and those two vehicles at any one time. There are two sorts of navigation that go into HYPAC. So we have a USBL, which stands for Ultra Short Baseline. And what that does is gives us our ultimate geographic position on the seafloor. But when we work at depth, the error in that can grow vastly. So the deeper we are, the less accurate it is. And so we end up with a few scatter points sort of around the area. So what we actually use for surveys like we're doing at the moment with the mapping is something called Doppler navigation using our DVL. And that gives us really good relative positioning. But what it can't do is it can't tell us our absolute geographical position. So what you might hear us saying sometimes, or the pilots and the navigators saying, is Doppler reset. And what that means is we're resetting our Doppler navigation to the location of where the USBL is giving us our ultimate geographical position on the seafloor.
Okay.
Oh, sorry. I was going to keep going.
Keep going. No,
There's more.
I appreciate it.
There
Okay.
is more. There
Great.
is more. Our navigator also works with our data logger back here. So we've got Aubrey, who
Are you not
is
worried about the tether?
frantically writing notes whenever we're doing any of our samples. And so we're able to actually drop virtual markers or waypoints into HYPAC. So our HYPAC screen is covered in markers where we've taken samples and also where we have our target sites as well. So our team ashore have been giving us dive plans every day with our target waypoints. And so basically we use HYPAC for a whole multitude of things, but it's basically our mapping and navigation software for the duration of the dive. And our navigator is always zooming in, zooming out, looking at distances and bearings and dropping waypoints. So yeah, it's a really useful piece of software for us to actually be able to execute these dives in quite a timely fashion.
So when other scientists want to replicate your experiments, this is shared with the scientific community through your publications. Is that correct? Or how is that done?
This is more an operational piece of software. So we use this operationally while we're in the seafloor and while we're in the ROV van. All of our other data, so there's a lot of data that comes through the telemetry from the vehicle. So all of the data that's sent back from the vehicle is being acquired at different baud rates. So every second, every 0.25 of a second. And actually that's the data that we would actually utilize. But what we're able to do is tie that navigation to all of those data strings. So we don't actually export as such the data from HYPACK. As I say, it's more operational. We
Right.
will use the virtual markers on the seafloor, like you say. So if a
So do
scientist
you want
in
her to
2, 3, 4, 10, 20 years'
so
time wants to relocate
Herc-
this vent site,
Herc
we
can
will
go
have
south.
accurate, as good
We're
as we
already
can
gone
get
over the vent.
navigation on the seafloor.
That's it there.
Fantastic.
Long
Thank you.
since
You're welcome.
passed. Well, I'm a little bothered.
You lose
I'm
Doppler
very
right now?
bothered.
Yeah. Good.
Perfect.
Well, you've tracked a very consistent line then.
Yeah.
Look at how
Should I head
consistent.
down?
That's good news.
You're
Yeah, it's really good
there
news.
for now.
Yeah, that means we got right over it. We got the data.
Yeah, that's great.
Nobody seemed bothered.
Yeah, I think the ship's just finishing up its move. It's good there too.
Yeah.
That's great. And we're not
And that
seeing,
puts this in line with that, which is where we were happy with to start with. So that's good.
Yeah.
and are we seeing any of that fluid in your
Okay, you guys are
multi-beam
coming
data,
down
or
again.
is it actually just
Not
going
this-
straight through the
Not this
seafloor?
time.
Oh, great. Well,
Large
this is
swell.
great
We were
news.
Go
directly
another
above
20
it, so
meters.
Really large swells.
Yep.
refractions,
Perfect.
the issues
The
matter a
ship's
lot
still
less.
finishing up, and we'll still see.
Yep.
Yeah,
that
and
You're
it's
looking
supposed-
straight down, right?
Thank you.
What was that, Cassidy?
Like 5-meter swells.
Doesn't,
Nice.
okay, I thought it would still have an influence on the.
Yeah, it might. It might just not be as intense
It's probably
as
not
the
as.
other one.
I think that's it. I think because we're that little bit higher, that maybe it's actually not.
Yeah, I don't see anything from it at all.
That's great. Makes processing a lot easier for you.
Sure does.
I think it's nice if I just keep moving when I'm over top of it instead of trying to hold a constant depth, constant altitude, and that's helped a lot, I'm sure. Instead of
Yeah.
instead of getting stuck in this weird feedback loop of hot vents, I just keep cruising.
Right.
So maybe this depth thing is the way to go.
Well, it's on the tether.
Hmm.
He's hitting the bottom, just out of frame now. It's coming into frame now.
Detritus.
Detritus.
Dead stuff.
Don't know.
Fido, one more time.
Phytodetrital fallout.
Yeah,
Phytodetrital
Yeah.
fallout.
Has a rhythm to it.
it does.
Phytodetrital fallout.
Doesn't matter. You can go this way now.
This little collapse feature is
sure,
really
south.
cool.
South sounds great, actually. Yeah. Because I have 20 meters to the end of my line. Is that true?
It's actually really cool going this way, actually reversing over it, because you can see the bathymetry first, and then you can
15, Roger.
reconcile
Yeah,
with
we'll
what
make
you're
that.
seeing
So,
in your
yeah, you can
bathymetry
switch
versus
it
what
in.
we're seeing in the
Whatever
Herc
you-
view, which is really nice. So we're seeing this like
let's go this way, actually.
scarp
Let's
collapse
go that way.
nicely now in your bathymetry. It's really, really cool.
For those tuning in, they have already sampled areas and taken samples of water to determine the chemical composition, samples of rocks and mats in the area to look at the microbes. So to answer your question, they have explored that. We're coming to the conclusion of this dive in the next few days. And
Did you catch the bucket lid in your sonar, Chris?
Not this time.
Okay.
We will be referring back to these maps and using that data.
Heading down.
Roger.
Stopping at 10 meters.
Yeah, that's
at
good.
the bottom. That's my
This is very
attitude.
cool. It's really cool. Really, really cool.
It's really cool.
Hey guys, isn't this cool?
It's super cool.
It's cool. It's hot.
Actually
man.
hot.
It's hot.
Right, exactly.
There you go.
Exactly.
Hot stuff.
So does it look like we've gone over all the venting, the extent of the venting already? I don't know if I see any more.
We just went directly over the top of it, so
Nice.
yeah.
I think it'll be interesting to see where we settle out on Herc now. I mean, we've got, how many more meters have you got to go? 10?
5 meters to go, I think.
5.
Ish.
Yeah, to the edge of this border.
Yeah.
But we may even have some extra.
Okay.
It's good to know that we got the extent of the venting.
Yeah, we're still seeing some coming in Hercules
really?
now, so
Oh yeah.
Heading down.
Yep.
So
Yeah, you just did 10 meters over? understood. Yep, that's fine. No, you're right. 10 is great.
So this region on the west coast between California and Oregon has thousands, several thousand or maybe 1,000 methane seeps.
So Chris, at the end of this move, I'll step to my starboard.
Okay. Yep. Another
Happy with
15.
that?
Yep. Another 15 meters.
Sounds good.
So how would they determine that? The
The ship move that
methane
direction is
seeps?
already complete, so we should see Argus move that way pretty soon. And I think you can start these moves now, 'cause now that we're
Great,
at the end.
Roger.
Okay, I'm gonna do that then. Starboard.
So you're putting our
Starboard.
starboard move now.
Yeah. This might stretch us out quite a bit, because that ship move's only finished a couple minutes ago,
Okay.
but we'll see.
We shall see. Do you think some people say starboard and some other people say starboard? Do you
I
think
don't
it's a
know.
regional thing?
I don't know if anyone actually says starboard.
I
I'm
say
sure there's
both.
probably
It's only
someone.
been.
Yeah, I have problems enunciating certain words.
Guys,
So
I'm
thank you for
sensitive.
pointing
Leave
that
me
out.
alone.
Cassidy. No, I'm joking. Starboard.
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 Starbursts.
Apparently I say water quite weird. so
Water.
Water.
Maybe it's a Boston thing.
It's not
where
weird.
you're
It's
from?
just your regionalism. It's
You
okay.
from Boston?
The water
Boston.
from Boston. What region in Boston are you from?
I'm just west of the city, so I'm on the Brookline-Newton border.
Nice.
That like
Yeah, but your accent isn't. You don't have like that classic Southie accent.
yeah, I think it's quite like provincial where it is.
Oh, we
Yeah.
have multiple Massachusettsians in here.
We do. Yes.
Uh-oh.
Shout out
Right.
Massachusetts.
Shout out to Cape Cod.
Yeah, so you've gone about you haven't lost DVL, right? No. right?
No.
Yeah, you're about 12 meters.
So do we have any geologists who could answer questions? Someone
I can see the
on
overlap in
one that
in
says it looks like
Oh, northeast.
His
there's
thing
a
too.
possible landslide
Northeast.
in the middle.
Northeast.
or
Do you
bird.
agree, or you really wouldn't be able to determine that?
So that should be about 15 meters there. Chris, do you want me to keep going? Are you happy with that kind of overlap?
Yeah, if you
Yeah,
want
we could go. Yeah, put in
Awesome.
another.
Another
few
5?
Another 5. Yeah.
Step and starboard.
nice.
So now we will be stretched out, so you'll probably have to spin around.
So I'll spin. Oh, wrong one. I'll spin starboard.
Yeah, so this ridge kind of bends out to the southwest. So if this move, you accommodate a larger move, it'll be nice because you'll get on the other side of the ridge more likely.
Roger. I love seeing the ground at Argus. It's so
Yeah.
exciting.
This is probably good right here.
The ground in Argus.
Yeah. Okay.
Okay,
That was a
I'm
total of
directly
19 meters, Chris.
the
Okay,
same
perfect.
orientation as you. I should probably be.
All right,
90.
we can.
I should
We
probably
can
be in 45
head back up
degrees,
slope whenever
right?
you're ready.
Yep. Yeah, 45 is the right number.
Yeah.
Put in 40 already. Roger that. I'll start moving up slope.
So should I head down?
No, I'm coming up slope.
I'll head up.
Yeah, you should be at like 130 again.
Yep.
So for those following at ISC, this is our third line up slope. And we'll give you an update as to whether we need to complete a further line after that.
I can do
Yeah,
this
it looks
back.
like we pretty much got it.
Yeah?
I think. We could do one on the far side of the survey, but I think we kind of started right along the top of the ridge on the first line.
Yeah.
So we have a few occlusions on the
So you're going to have
on
some
the
drop-offs
on the
there.
lower part of
Yeah.
on the lower part of the ridge. But by the time we got it by the venting, we had already crossed the ridge. So we've pinged it from both sides near the venting sites anyway.
Maybe towards the end of this line, we could do a zoom out on your visualizer and let the folks at ISC have a look, and then we can make a call
Right.
as to whether we want to do a back
Well,
move
we can-
and do the.
We can do that now, actually.
It's pretty high
Okay.
on the delta.
Oh, sheesh. Sorry. I'm zoned out.
Okay, I'm going to add one more.
Yeah, so you
You're
see,
gonna have to come down before we can
you
continue.
see here we have a
Yeah,
couple big
sorry.
holes.
Okay.
What's that, Chris?
So well, I'm talking to the folks at the
Oh, I understand.
to Lee and ISC. Yeah, so you can see there's a little bit of the ridge outline there.
Yeah.
And then we kind of sat on top of it, so from here on up, we're okay. But
Got a
we could
couple-
grab one more line on that side if we wanted to get a better picture of the whole
What's
thing.
your delta
Yeah, the
depth?
bend in the
Okay, we'll
geotech.
stand by to hear from ISC if they think
Ah.
that's necessary. But I mean, if you're happy,
Are we-
20?
we'll see how we're
Yeah,
doing
I
with
mean,
time at the end of
we
this.
have we have some data there. It's
Yeah.
not
I'm
like
not
we
going
have-
to come up, which
it's
will
not
make
like
it
we
about
have nothing,
15, but you can stop there.
And as you say, we've got the main venting ridges.
We'd love
do.
to have that extra coverage on the other side.
Okay.
Great,
Awesome.
thanks for that,
Yeah,
Shannon.
we can
Okay.
do that. That's not hard.
Yeah.
What were we doing?
So did you get that, Ben?
Yep. So you're talking about the
Yeah, so
occlusion
that
on
we're going to
the-
do another line north of the entire survey.
So
Understood.
my
Parallel
question
to the
is
existing?
on the
Yeah.
southernmost part of
Yeah,
that
so it's
northern ridge.
it's
did you
basically
get-
going to be on the 1-2 line there.
Understood.
We're basically going to do that.
And Ben, I
we'll
think
just
Ben's got
kinda-
one more question,
Oh,
too.
no, that's fine.
Yeah.
So the southernmost part, did you get to the other side of the ridge? Because it looks like it bends.
The southernmost part we did not. Or
Still?
sorry, the southernmost part. Yeah, we did.
Yeah.
But we might as well do the whole line.
Major
No, that's
swells.
great.
Right.
It's the geotest translated a little bit, so
Yeah.
it looked like.
Look at this. It's like
But by the
7
southern part, you
meters.
should have gotten it.
I think you can
Hopefully.
spin to starboard now and get me in view. You should be able to. And then you can come up on delta.
And Shannon, I'm not too sure if you heard, but I think there was a question from Nautilus Live regarding almost the collapse we saw in one of the ridges and what might have caused that. I don't know if yourself or anyone at IC has any insights as to what that could be or
We'll go way
how
over
that formation
yonder.
might have happened.
Yeah. Okay, that's fine. Yes.
– 17, 16.
Sure.
I feel like I'm in an eye doctor's office. Better or worse?
Yeah.
Better? Worse?
Totally.
I was wondering where you're going with that.
Higher or lower?
So for those
Okay, now
tuning
we'll wait for
in,
the ship.
you may be interested in visiting nautiluslive.org
Kinda zipped ahead there.
expedition page to learn more about what NASA's subsea systematic underwater biogeochemical science exploration analog
Say what?
is. There's a summary there, and
Yeah.
we're being led by
I just looked
Dr.
up the beam width
Darlene
of the ship the
Lim.
other day, and I cannot remember it. Saved
She
my
is
life.
the PI for this particular expedition, principal investigator. You can find additional
That would be a good
information
one to
at
know.
Space Science.
It's a good one to know, because that way you can judge how far those are on a screen that doesn't show you.
arc.nasa.gov/subsea/.
Argus? The ship. Oh, you mean this part of the ship? You can go quite a bit more.
Dr.
We wanna
Andy
get down to
Smith
here.
and Dr. Sarah Hu at Woods Hole Oceanographic Institute
So before, can you zoom out one click?
will be conducting the microbiological studies
Yeah, let's see where we went.
upon the samples obtained.
Before we
and
went down there, from there. So we went another, I don't know, 70 meters. So we
Geologists
only want to
are
go like
also
50 or
involved
30 or something.
at the Inner Space Center
Yeah, great, you
in
can keep
Rhode
going.
Island.
No.
And I will
think,
later give you the information so you can follow their Twitter account as they
oh, sorry.
collect their data.
Wait, what am I? Argus is north right now, so I don't want to come more north, more northeast. Okay, stepping forward again. And coming up.
You're going up, so I'll go up.
Pardon me?
You're going up, so I'll go up.
Yeah.
You can also go to the records
That's
at
probably
the
fine.
Loihi site
Okay.
that they went to last year
So now we're starting to pull
in
the tether
Hawaii
again.
to look at the thermal vents there.
Is this the tether?
That's just noise from something.
Maybe a tether.
Tether noise, yep.
Yeah, I don't know, 'cause it's like in multiple locations.
675 kilohertz tether.
What would that equate to? So what is that representing?
This thing?
No, the 600, you said the 600.
That's the frequency of this sonar. I don't know the frequencies of the mesos. I've heard them. I don't know. Anyway.
Some more, wow, look at that. There has to be
The
something, it's
scientists
not
have
just
been
noise.
collecting the venting fluid and rock in the area to determine the biogeochemistry of the area.
You don't think it's noise?
I don't know what it is. That's weird, that was just an arch.
Mm-hmm.
It's in and out. Where is this on Argus?
It's on Herc.
It's on Herc. It's in the back bottom,
It's the forward top.
forward top.
So, or forward in the bumper bar, in that little notch between the two jut
Oh,
out
that I felt the
parts.
oil?
No, that's stuck in the foam block. It's forward of that and up on the bumper bar. Also, watch your delta coming up.
Oh, sea prints.
Sea prints. Precisely.
Okay, stopping here.
That looks good.
Bye, Jess. Good night. What a sweetheart. Oh no. What a sweetheart. We got 2 hours and change.
The change is what'll get me. All right.
We are off the coast of Northern California and Oregon at Gorda Ridge. NASA subsea scientists are collecting samples and venting fluids, microbial mats, rocks, to study the composition of each. And we're using telepresence to transmit this information to scientists on the ship, as well as at the University of Rhode Island in our Space Center. A team of scientists are involved in this exploration. By the spreading of the plates here, we're at the bottom of the Ondefuka plate. And there is a lot of hydrothermal activity. And
Bless
they
you.
will be exploring and learning about the
Headache up.
thermophiles the organisms that can live in these extreme conditions, also known as extremophiles, but thermophiles are specifically the ones that can tolerate hot conditions. And also, excuse me, extreme pH as well.
Yeah, great. I'm lining up for that after this.
Sorry, I'm a little low here. Sorry, from the end of my line right now. Great, yeah. Sounds good. Yeah, ship move now would be grand.
Bridge.
Heading up.
Thank you.
You know, Chris, if you kind of look at your map, it looks like an abstract painting of like a sunset over a beach. Anyone else see that?
It looks like those, there's a style of paintings that, or style art that happened in like the early 90s, late 80s kind of thing that was like that way oversaturated sunset colors. And
Sublimism or something.
is that what it's called?
But I think it was the 18 something.
And friend.
Right? 1880s, 1890s.
Oh, that's different then.
Okay. Like the slave
It was
ship.
like the ocean had waterfalls in it and stuff, like kind of absurd, but like,
Lisa Frank.
I don't know. I won't recognize it if I hear it
Lisa
either.
Frank.
That's K2's favorite artist. Chris,
You're
the
adding a sign.
visualization is like the points are decimated from the raw data you're actually collecting. That's correct, yeah?
Yeah, that's right.
So
Yeah,
we're missing
otherwise
a
it just
little-
gets too much to visualize.
Yeah. And you have a certain trail age of points that are shown.
10 minutes.
Cool.
How far am I to the end? 10 meters or so?
Maybe less than that.
Okay.
Yeah, 10 meters. 8 meters. So we're going to do a total move probably of, let me see. If we're going to be 15 meters north of the northernmost line,
Thank you.
Yeah.
we're going to do like 50 meters to
50 meters
to port.
to my port, roger.
But once we get there.
Once we're finished
Yeah.
the moves. I'll go probably a little past this. I'll match the end of the line. Good catch. Oops. Oy, oy, oy. Stop that. Hey, come back.
Yeah, you're at the end
Paul
of
and
the border
George.
file now, so.
Roger. I'll
That's nice.
flush it up to the edge of the
Yeah,
sonar
get as much
target,
as you
then
can.
I'll move to port.
We went about like 5 meters over last time, or 4.
Roger that.
Which is nice.
I think I'll just go till this one looks right. Mamma mia.
Mamma mia.
So,
Oy vey.
I'm way too low.
See a cucumber and a shrimp.
Where?
Right center screen
Where?
on that rock. Looks like a little worm.
Does it look like a cucumber?
That pink cucumber.
That's not a cuke at all.
I would rather have a regular cucumber.
okay.
Going up on Delta.
Thank you. Okay, Chris, you're cool if I step to port now? Okay, step in port.
Yeah, if we keep parallel with these lines, you should be about 135, 140 from.
So is this to do our
Okay.
large step to port to be able to collect that final line
Correct, yep.
for ISC. Great.
Mhm.
Copy that.
So feel free when I come around here to take your wrap out. That's whatever point you think is
So
best.
ISC, we're just about to collect that
Half a
final line of data for you that we missed at the start of the survey. So hopefully we'll get another line there. If you look at Chris's visualizer, he's got it all up now on your screen.
So where are you going to be heading?
I'm going this way, probably 50 meters.
Okay.
Yeah, we're basically just going to go down in the fuzzy bit here. Try to get a little better data.
The fuzzy bit.
Sounds good. Make it less fuzzy.
Yep, less fuzzy.
Defuzz it. Shave the map's beard.
Gotta have some fuzzy parts somewhere. That's how it works.
I think you're right.
Cucumber.
I encourage you to visit nautiluslive.org.
So the fastest way to spin is about
to look at
90 degrees,
careers
having your yellow bar, yellow
and
dot,
the
like 90
education
degrees off your set
tab,
point.
opportunities
Sorry, your set
to
point 90 degrees
serve
off your actual.
as
and
a
then
science
as it
communication
moves, just keep it
fellow
90
or
degrees away.
ambassador if you're a
Roger.
teacher,
Yeah,
but
that's
for
the
internships
I'm gonna add 10
for
meters and that's it.
for
Sounds
college
good.
students or recent graduates. There are numerous opportunities for you to apply and participate in the exploration upon Nautilus. I also encourage you to share with your family, friends, community centers, museums, churches, the interactions, live ship-to-shore interactions that are available to speak directly with someone for 20 to 30 minutes aboard the ship. It's a great opportunity for young people, particularly students, to see the dynamic interaction of careers, different
You've got good taste.
majors,
We should come in
etc.
here.
Because people are from diverse backgrounds. For example, in this control van right now, we have the scientists in the back row who are directing what they would like to see, as well as at the
Almost like we
Interspace
planned it.
Center. And then in the front row, there, I'm sitting here
That
as
is
a
always
science
how it is, I think.
communication fellow, communicating to
Figure
you.
out how to do stuff
And then
the
we
right
have
way,
a video
right before the cruise is over.
engineer who then is
Standard
directed
operating procedure.
to direct the cameras.
It's written in
or
the
to
SOP.
zoom in,
Yeah.
zoom out. We have the
Step 1, do
Argus
it wrong.
pilot.
Step 2, do it right. Step 3,
The
finish
Hercules
cruise.
pilot, and the navigator. So this is a totally comprehensive project with people from diverse backgrounds involved in their objective, a common objective to get the job done. So it's a great opportunity to explore careers as well. Exploration in everything.
So I think this is going to be my last move of my self.
You mean your tether?
The vehicle. Like, I don't think I'm going to need to... I've been punching in moves. I think this will be my last one.
Oh, I see what you're saying. Yeah. So
I don't know. Maybe another
let me
5
show
meters
you.
after that.
Let me show you.
I got kitchen.
I got you.
What's that blue line, Chris?
The origin.
Oh, wow.
The origin of the entire
Of
Earth.
everything.
Origin of the universe.
Capital
For-
O.
For
Period.
for today, that is true. Yes.
Wow.
There it is. See, there's a red line and a green line.
Is there a blue line too?
So is that
Yeah, well,
the
that
end?
was the blue one. That
The
was the
end
one
of
that
the
you were
universe?
seeing.
There you go. The sun
right
wraps
there.
We'll
around
put
that
it-
origin.
That's where
We'll
all
put it
happened.
right
Wow.
there.
Wow. I'll do 5 more meters.
Yep, that's right.
That's right.
That's the right meters.
That's the
Thanks,
right
Ben.
All right,
amount of
I'm going to
meters.
start moving towards the bearing of the line.
That sounds grand.
Grand. Get a little curl.
Yeah.
You could probably grab another 3 meters to port, too.
3 meters.
Let's
Roger.
do 3.
We're getting crazy over here.
Oh, wow.
Here comes 3.
Yeah, I just want to make sure that we end up
Hey,
well
George.
on the side of the ridge.
Uh-huh.
Hey.
Howdy, George.
How does that make you feel, Chris?
Happy.
Let me see. Yeah, this is good.
This should be the farthest distance you are from the ridge,
Yeah,
according to the geotip. So.
Yeah, let's step back.
Roger. I'll let the ship is moving, but I'll let Argus see that movement, and then we'll start stepping.
George left.
I think he was working.
He was in here expecting fire extinguishers.
Yeah, it was not
That's
a
appreciated.
not a social call.
There's some more vibrations back in the Argus cam.
Mm-hmm. Just out of curiosity's sake, how are our offsets doing? Where's my USBL? I feel like I'm over here. Is that true? Or
like you're over there.
All the alignment on the map is still pretty consistent, so.
I've actually,
there's one.
when I was watching the southern part, you looked a little bit to the north of the USBL pings, but it looked good to me,
Okay.
to be honest, so.
Great.
Because this is from you transiting it over.
There's one.
Oh.
Yikes. Oh, there's one. Yeah, okay.
Yeah, I think
Looks
it's been
happy.
good.
All right, we're good to step whenever.
Roger, standing by on Argus.
Got it.
No matter how much we preempt.
Yeah, well, you know. This one was where there was a 30-second gap, and that wasn't... Look at this. It's like a child's crayon drawing. Yep. Good paper.
I encourage you to follow Nautilus Live this summer, even if it's for a few minutes each day, just to look at the different expeditions that are occurring. And if you go to nautiluslive.org and you look at the expedition page, you will see the map of their expeditions that they will be doing until October. So there may be some others that you're interested in. And then you can write your questions in the box at nautiluslive.org. And the Science Communication Fellows on each expedition will hopefully address those questions. But they're quite diverse. Each expedition is different than the prior. So I encourage you to explore. You may discover something entirely new and different. Thank you.
Okay, I'm going to start stepping. Step, step, step. Step, step, step. Step your Norbit.
We've all been thinking it.
Let's see.
Yahtzee.
Yahtzee. You can come down on Delta now.
Roger.
How is this for altitude, Chris?
Perfect.
Thanks. No, you're perfect.
20?
Sure. I am going to let the ship go ahead again.
Okay.
I caught up in a hurry.
Is the tether too low?
It's okay. No, you're right. You're right.
I make the calls.
This is my vehicle.
I'm the captain.
Sorry?
Nothing.
Look how much.
I'm the captain, yeah.
I am the captain.
Look how much layback we're gonna have at the end of it.
Yep.
That's how it happens.
That'll happen.
It happens.
Happens to the best of us.
It's unavoidable.
It's practically unavoidable.
It is.
Literally unavoidable.
Literally.
If Arcus is here, that means Herc is here, and you need to go this way. Wait, it's not working. It's not working. It's math, it's physics, leave me alone. I'm gonna head down. Yeah. I'm gonna head up. There you go. That's okay. I fixed it.
So does anyone know the pH of this area? Someone's curious about that.
They won't know the pH right now, but when they get samples back on board, I think some of them are doing pH sampling.
Okay, thank you.
Stepping aft, yep.
So
And coming down.
someone thinks that Nautilus,
Roger.
we're a beacon of light in our oceans, because there's one place in the world someone can go and watch people from all over the world doing something constructive, not destructive.
You can come down on Delta.
And they
a bit
love
now.
you
What
for
a
that.
beautiful thing to say.
Mm-hmm.
Cassidy,
Thank you, audience.
you can come down on Delta.
I can honestly say all the people here are delightful. There's just been a wonderful group of
There's a
people
lot of variants.
to work with.
Why don't you spin around 180?
Sure. I'm gonna, should I do it port?
Sure, it doesn't matter. No, you're already going starboard. Keep going starboard.
There's a wrap.
That's fine. Yeah. Just because this heave and this angle is not super great. If you give me 030, that'll be perfect.
Okay.
To comment upon someone asking about how I plan to share this with my students, I think what I've observed here as far as the collaborative efforts here of all the scientists, technicians, and people from diverse backgrounds, how they all work together for the common objective. I hope to simulate something like that for my classroom, so that students understand that each person has a certain talent and skill that they can bring to the group, to the team, and that they will achieve a common goal. So I hope I can develop that, because I've actually witnessed it, that it can happen. And it, like I said, it's been delightful watching everyone work well together and having their specific role.
Yeah, Susan, I agree. It's a team effort. 100%.
Mm-hmm.
Chris, how's the overlap looking for this line?
Overlap is looking just fine.
Good.
It's fine. Everything's fine.
Fine, fine.
Everything's fine.
I know in our society
wanna talk about it.
we look at the
I don't wanna
athletes
talk
and the
about
teams of, and give them such,
It's pretty steep.
recognitions, the teams of athletes, but I think the teams of scientists globally who work together to develop technology and what they research and their discoveries, they often go unnoticed, and I think it's really critical to address that. They do amazing things.
Sure, we can overshoot.
Bridge nav, can I have another ship move bearing, same bearing, just 20 meters?
Doesn't hurt to overshoot it.
So Aubrey, someone would like to know that when the water samples are taken at that depth, do they smell different than
Bridge nav, did you
water
copy
in
that?
shallow areas? Or do they smell like, quote, whatever is normal ocean water?
So I would say it's not necessarily the depth, but more the specific location at this depth. It has a very sulfur smell when it comes up. But if you would
Come
take
down on
another
Delta again.
sample at this depth,
Yeah,
not
sorry.
near a hydrothermal area, it could have a very different smell that would simulate more shallow ocean waters.
Okay, thank you.
Is 030 still a good bearing? Heading. Is 030 still a good heading?
Chris at the Inner Space Center, that question about how the ocean smells. We
Yes.
actually have Herc smelling the ocean as it's mapping it right now.
Really?
We have as well as the sonar that K2 is using, we have a thing called a mapper, a miniature autonomous plume recorder on board the Herc, and so it's measuring chemical properties of the water as it's flying to and fro. So one of the things that Shannon's team with Ashley and Angela have been doing this week is merging that data with the sonar data that K2 is generating to be able to tell not only where the lumps are on the seafloor, but which ones have the effluent coming out of them. So we can actually use this as a mode for exploration to how to find active hydrothermal vents on the seafloor.
Oh, great. Thank you. So perhaps you can answer a question I had earlier. How do you determine the methane versus the hydrogen sulfide
Roger.
Vents? I mean, like on the surface, is there any way that you can determine that superficially without having to go to the depths so that you know where to discover? I mean, not discover, to study to make discoveries.
We can't. The water that comes out of the hydrothermal vents, it mixes quite turbulently and quite violently with the seawater around it. That's what makes all the weird and wonderful Schlieren effects that we can see in the video. So although the water is buoyant when it comes out of the ground and it's shooting upwards in jets, it kind of runs out of momentum before it gets more than a few hundred meters above the seafloor.
Mm-hmm.
So most of the chemical staining never gets near to the ocean's surface. So we actually have to lower instruments into the ocean to actually sniff for these things, and so that's really part of
Chris,
what we're
is it
doing
a
right now.
coincidence that it seems like
seeing which sensors
how
we can
when we're
use
going down the slope, we're
to go
like
and
following these
sniff
little
with
micro
robots
valleys?
to go and help find our vents
that by
more
design?
effectively, so we know where to come to in future years with Herc.
Okay, thank you. So when they're saying there's over 1,000 methane seeps in between California and Oregon,
understood. Yeah.
That was mapped previously by other expeditions then, correct?
Not quite. For the methane seeps, they're shallow enough that they actually they give off gas bubbles. So those show up. They do show up in the ship's sonar.
Oh, okay.
So you can actually see the columns of gas bubbles rising up towards. They don't necessarily break all the way to the surface, but you can see them down deep.
Hurricane Ridge.
That version of deep is not nearly as deep as where we're working.
I remember that name like 4
whilst there's
weeks
1,000 seeps that have been found along the coast of the US, before that sonar technique was used, there were 4 seeps known along the coast of the US, certainly on the Atlantic, as recently as 2012. So that approach revolutionized that kind of exploration.
Thank you.
For mid-ocean ridges and hydrothermal vents, everything is much deeper, so we actually need to have either robots or other equipment that can go deep and can actually find other ways to look for what's coming out of the ground.
That's not so bad when, it's coming out behind you, so it's not so bad.
Thank you. I appreciate this information.
Just keep stepping.
Hi Chris, it's Lee here. I just sent a message via side chat about your thoughts and the rest of the IST team for the remainder of the dive. So happy to have a chat through whenever you're ready, or we can have a talk through so that we've got a plan at the end of this line as to where you want us to go to next.
22 is too high.
That's not bad.
Okay, I'll get to Shannon and we'll have a look at the side chat message.
So. Yeah, that's great. Thanks Chris, appreciate it.
Not a lot of loss. Not a lot of loss.
Not a lot of loss.
Not a loss.
We are off the coast of Northern California and Oregon at Gorda Ridge with NASA subsea scientists exploring hydrothermal vents, collecting data, information on geological information and microbiological samples as well for Woods Hole Oceanographic Institute scientists.
Look at this
Dr. Darlene Lim is the principal investigator for this expedition, and doctors
So we know what this
Sarah
distance is.
Hu
So
and
I'm
Dr.
just
Amy
interpolating what it would
are
be.
from
So this, if like
Woods
a
Hole
finger length is 10
Oceanographic
meters,
Institute.
this is like